So, you know, we had these two boxes in a row. Whenever there are more than two boxes in a row, you're going to do one-way analysis of variance. And when I say in a row, I'm using those words very specifically because it's just going horizontally. We're adding more boxes to the right. If we add more boxes above or below, it's something different. So just the line of boxes now, instead of being a line of two, is a line of more than two. So analysis of variance could be three, it could be, have 5 different treatment groups.
And there's a one-way, there's a two-way.
And there's a three-way. There's probably a 4-way, but I can't draw it. Yes. But we're starting with one way.
All right.
Okay, so one-way analysis of variance means that there's one dependent variable.
Yes, there's one dependent variable. How many independent variables are there?
More than two.
One.
Oh, sorry.
Yeah.
Right. Whoops.
So
I meant.
would it be accurate to say that the number of boxes is representative of the number of groups and not the number of like instead of having two independent variables, you have one independent variable and you can have innumerable groups.
Exactly.
Okay.
Exactly.
Okay.
Wait, say that again.
Got it.
Say it again.
You get this.
I do get it.
I know you get this because you proved it to me yesterday.
Yeah.
But say it
Say it
again,
again.
Ashley.
You can have one independent variable and innumerable groups.
Within that independent variable. So the independent variable is treatment, and you can have one treatment and a control, or you could have 2 treatments, or 3 treatments, or 4 treatments, or 5 different treatments, but still it's which treatment did they get, and that's the single independent variable.
Or your independent variable could be like grade level, right? So you've got...
Right.
Yeah.
Is there a difference in singing voice use according to grade level? And I might have first, second, third, fourth, fifth, sixth, yep, that's 6 different groups. And grade level is the independent variable and singing voice is the dependent variable.
Which is why the author of our homework article used analysis of variance, because of grade level.
Okay? Are we happy so far? All right.
I'll get it there eventually. Don't worry.
So look at your designs for differences. Where's the first one that uses one-way analysis of variance?
Thank you.
So what do you think?
It's 4.
Right, 4. How about number 5? Does that use it? Yeah, it does. How about number 6? Yeah.
Would it be? It wouldn't be one way, would it?
Yep.
Oh, it would be.
It's just displaced by time.
Oh.
Yeah, yeah. How about number 7? Yeah?
Yeah.
How about number 8?
It's 2-dimensional.
Right.
Yeah.
So, yeah,
That's not
what,
a word I'm prepared to dig into yet.
but it was right. And there's one more.
Wait, the answer to number 8 was
No.
no. Okay. Just check.
Yep, 15, exactly. So all of these, and the question is still, is there a significant difference between the means? It's just now you're looking at 3 means, or 4 means, or 5 means, although all your pictures here just show 3, instead of 2. So this one-way analysis of variance is not very it's hard to do mathematically, and we're not doing it mathematically. I'll show you how you enter data in a computer. But it is not very hard, and these are called F-tests. Sometimes you'll see them called F-tests. It's the exact same thing. Because here, please don't ask me why it's F. Because that's another one of those, I have absolutely no idea. But instead of yielding a T, it yields an F. And there are F tables that you can look them up on with critical values, just like there were T tables. We're not going to do that. So look in your pile of goodies at excerpt 12.7. So, and to the extent that you can read through the dense blackness of the text, please read it, and then I'm going to ask you what the independent and the dependent variables are. So what was the independent variable here?
Ethnicity?
Yeah, type of ethnicity dyad. So type of roommate dyad, what kind of ethnicity grouping is it? What was the dependent variable?
Roommate satisfaction.
Yeah, roommate satisfaction. Okay, so was there a statistically significant difference in roommate satisfaction according to type of dyad? What do you think, Dan? Was there?
Yes,
How come? How do you know?
there's a star.
Right, I love those stars. Yeah. Nothing too tricky about that one. If there hadn't been a star, how might you have been able to figure it out?
You could go to your,
Not the chart.
no, not the those.
Can't go to the T table.
No, can't do the T.
No, you can't do the T-table, but
No.
there is something on this chart that'll give you another hint.
Less than .01.
Yeah. If it had not been statistically significant and they'd made the .01, they would have put P is greater than .01.
May I say that again?
They would have turned the greater than or less than sign
Yeah.
around
If,
if it had not been statistically significant. All right, so how would we change practice as a result of this?
Oh, I don't think we know.
Yeah.
How come we don't know?
We don't know which groups.
Yeah, right,
We don't
exactly.
have WASP or whatever.
So here's the thing about one-way analysis of variance. It tells you that there's a difference somewhere, but it doesn't tell you where that difference is. And so if you had found no statistically significant difference, you know that none exists anywhere, so you don't have to worry about it. But if you find a statistically significant difference, then you have to do what's called post hoc tests. Mean tests after the fact, basically, to find out where that difference lies. And what those post hoc tests do is they're sort of, in some ways, an equivalent of doing a whole bunch of t-tests that tells you where the pairing is. And there are different kinds of post hoc tests that you can do.
Post hoc.
Hoc, H-O-C. And usually your computer will give you a choice of which ones. There are a couple different ones. And some of them are what's called more sensitive, more liberal or sensitive. Those are the same thing. It's more likely to find a difference. Some are more conservative. You're less likely to find a difference. And so these are sort of from conservative down to the most liberal. Chevet is one of them, and that's the one that's hardest to find a difference with. Then there's, these are so funny, Tukey HSD.
That was in the
Oh, yeah.
article, right?
Yeah,
Yeah, that was, yeah.
And in order to use that one, you need to have equal numbers of people in the cells.
Our cells are those boxes.
Big group.
Yep,
Okay.
exactly.
What are these
Cell-
boxes of which you speak?
Cells are the boxes.
These boxes.
Okay,
So the N has
So
to
like
be equal in all
20.
groups.
thank you.
Here's actually, did I spell that right? Yep. Here's actually the Taggart test of choice. And you don't need equal cell sizes for that. If I don't put equal cells, then you don't need them.
Keals?
K-E-U-L-S.
Is
Keals.
it starters because you like it, or is that?
Yep.
Okay.
And,
Taggart test or Taggart approved.
and I like it because it's sort of in the middle. It's, so people won't say, oh, you're using Fisher. Of course you found a, this is a funny one too. Fisher's LSD is the most liberal. How convenient. I can remember that one. If they look at, and you've done Fisher, they might say, of course you found a difference. It was the easiest one where you're going to find a difference. So I like doing the one in Newman-Cools because that's kind of the middle level of conservatism. It's kind of a nice one.
So, okay, so if you are, let me rephrase this. You mentioned a little bit ago the spaceship going in space have to be very precise in your whatever probability things.
Mm-hmm.
So people would want to use a very conservative post hoc analysis for something like that because then it would only be very like. Does that make sense?
Yeah.
Okay.
Yeah.
Stringent measure.
But with these, like with anything, you also determine your p-value.
Right.
So you can say I want 0.01 or I want 0.05 or I want 0.001. So, a 0.001 Fisher LSD is more conservative. You'd have to find a higher one than a 0.05
Okay.
Chevet.
Okay.
Yeah. Okay, so then what it will say is it will show you with each pairing which is different. And it might be, looking at that study, it might be that there was significantly less roommate satisfaction between the white and white roommate dyads than there was between the African American white, the Asian American white, or the Hispanic American white dyads, and there was no statistically significant difference between any of the three mixed dyads. It could be that any combination might be possible. And some things, it might be three are the same and one is different. It might be all four are different from one another. It might be two are the same and two are the same, but the two pairs are different from one another. So I always sort of like to think of it in, if I put them in order, according to mean with roommate satisfaction. Here's the lowest, here's the next, A, B, C, D, so there are the 4 different types of dyads. One of the ways to graphically represent it, that is that 3 of them are the same and 1 is different. Or A and B are the same, C and D are the same, but they're different from A and B. Or it could be that A, B, C, and D are all different from one another. Or A is less than B, B is less than C, and C and D are the same. So they aren't statistically different. So if this is so African American white, Asian American white, Hispanic white, white white. So I might say this was the one I just described. Only in here I did it happier. So in this set of results, if that's the least, that's the most. The white-white dyads were statistically more satisfied than any of the mixed-race dyads in terms of their roommate satisfaction, but there was no difference in the mixed-race dyads in roommate satisfaction. Or African American and white dyads and Asian American and white dyads were not statistically different from one another. They were the least satisfied with their roommate dyad. Hispanic and white dyads were the most satisfied, but were not statistically different from one another in their satisfaction. Or African American white dyad was the least satisfied. Asian American white dyad was more satisfied than them, but less satisfied than these other 2 groups. And take each one and say how it is in relation to one another. Here, African American and white were least satisfied. Asian American white were more satisfied than African American and white, but less satisfied than the other 2 groups. And these 2 groups were the same as one another, and they were the most satisfied. Does that... okay?
So, the order in which they're listed going this way determines their rank of importance. So, say that it was like A, B, C, B.
Yeah, it could be. I went in order, but it could have been any...
I'm just...
Yeah.
The reason why I ask is because everything on this side is what is really important, and everything on
Not
that side
what is really
or,
important,
I mean, what
what's
has
more?
significance and this has less.
Not more significance, it has a higher mean.
Yes, that's
Yeah.
So sorry, you would lay it out like that,
Um,
left to right?
I might, yeah. I think this is a way to graphically represent it that makes it clear to people. This is 4 different studies, but
what does each of these tests? Each of these tests gives you a series of values.
each of the tests will tell you if that pairing is statistically significant, and then you look at the means.
Okay.
So just like you did with t-tests, when you saw that there was a statistical significant difference, you said, okay, which mean is higher or which mean is lower if low is a good thing. And then you say that's the one I want, that's the one I want to talk about. So you're looking at each pairing and looking at the means to interpret the pairing.
So why do we do analysis of variance if this thing is so much better? Does post hoc have to use the data from analysis of variance?
No, because you will sometimes find differences if you did the post hocs and didn't do the analysis of variance first.
Okay.
And then you would be finding differences that didn't really exist. So if you don't find a difference in the analysis of variance, then you're done. You don't do post hocs. But post hocs are saying, okay, this told me that there is a difference somewhere. Now where is it? So it just prevents you from making a type of an error that you might make as a result of doing a whole bunch of things on the same set of data. All right, so let's look at,
Oh, sorry, can I ask?
please,
What's the SS?
Yeah.
some squares.
Oh, okay, never mind, turn the page.
Yeah.
And
That's-
does that mean square too? Is that?
Yes.
So, for our purposes at this moment,
Mm-hmm.
we can be content to know that this battery of post hoc tests allows us to determine where the variance is when we
Where the
know-
difference is.
where the difference is, and to understand that on a broad conceptual level is sufficient.
Yes.
Okay.
So look at the next thing. This is a statistics program. And this is how you would input the data. So for each column here, let's say that it was singing voice achievement. So the dependent variable, this was a study with 17 kids in it, which is not enough. But it's a study with 17 kids in it. Here are all their scores on the dependent variables, 1 through 17. And here is which group they were in, the no text group, the text group, or both. So that's how the computer then knows who is in what. So this is called a string because it's not a number, it's a string of letters. So it will ask what kind of a variable is it, and you usually have to choose a string because it's words, not numbers. And this, you'll have a chance. They usually say integers.
Couldn't you just assign no text 1 and text 2 and just have groups 1, 2, and 3, or?
Yeah, but if you don't call it string or grouping variable, it will analyze it as numbers.
Oh, okay.
So you want the computer to know that that's how you're doing the groups, not that they actually got a 1 on something. And I find that when I'm looking at it then, it makes more sense to me. I don't have to look something up. Oh yeah, what was the number 2 again? What did I assign to 2? Because it just tells me it was text. And then in the tables, it'll say text and no text, and it'll put the words there for you so that you don't have to look it up and so that you don't have to change it later. But I just wanted you to see this because this, I know when I started doing this, this was something that took me a long time to figure out how to just input the data in something like an analysis of variance. Okay, so I did that. And you can see on the next page the results. So I set my p-value at 0.05. How about it? Was it statistically significant? I mean, that's I wanted it to be less than 0.05.
No.
You're right, Jackie. Why?
Because it's more than 0.05.
Yeah, so when 0.9371 is a lot more than 0.05. So yes, it was not statistically significant, or no, it was not statistically significant, depending upon how you want to translate that.
I just didn't know which p-value to look at, but I guess they were all.
Yeah, they're all kind of stinky, if you're looking for differences.
Oh,
Now, really, you wouldn't, all you'd need is to look at that top table. Because if you know that there's no statistically significant difference, we're kind of done. But the computer spits out all that other stuff for you. You'd also have to report the means and standard deviations somewhere in there, so it's really nice that it gives you that table with the means and standard deviations in it. I must have been feeling psychedelic, and I chose the Fisher's PLSD, P as in post-test LSD. And see, here's how it shows you each of the pairings. The text with the no text, no significant difference. The text with the both, and the no text with the both. So it does each pairing, and you can see where they are see whether there's a difference. This one actually also does a graphic where you can sort of see that they are not different from one another. You know, they're all, those bars are all about the same height.
So will this extend?
Yeah.
The little thing on top,
That's correct.
that's the error of measurement.
Yeah, I was gonna say.
So if there's any overlap between between the bottom of the graph and this, it tells you that they're not different from one another, and there's overlap kind of on all three of these here. So we'll see more of that in a minute.
I think that was also in the study that
Yeah.
we had.
It was. I remember wondering the same thing.
Yeah. Yeah, good. All right. So let's look at the next one. Just to practice. So this was looking at, family involvement with children's homework. And there were 3 different conditions. So the family involvement is the dependent variable. How much did the parents and siblings help with homework? And one group, 3 different treatments. One group was no prompts. We're just hoping that they're going to do it on their own. One group, the students were being told to have their parents help them with their homework. And the third group, the students and the parents were being talked to by the teacher saying, help your child with your homework. Was there a statistically significant difference between groups? Yep. That happy little star again. Or you could have looked down at the P value below. And again, without doing the post hoc test, we don't know. You know, we can look at the means and we can sort of guess. My guess is that there was probably not a statistically significant difference between the student prompts and the student and family prompts. And both of those were better than the no prompt. But I don't know that for sure. I really genuinely would need to do the math to be sure. But you can kind of look at it and take a guess. All right.
Now you couldn't take though, this isn't enough information. You need all of the raw data, or not raw, is it raw? Like, would this be considered?
This is what the researcher, that's what you'd put into the computer.
That's what you.
This is what the researcher would put in the article.
In the article, right, and I guess you would never take something like this and then analyze it further?
No.
Okay.
Because you're right, you don't have enough information. All right, so look at the next one. Whatever SAI diffidence scores are, diffidence egoism scores. So that's the dependent variable. What's the independent variable? And how many groups are there? Right, 3 groups, a control group, a leader-structured group, and a group-structured group of therapy, counseling. Was there a statistically significant difference? At what level? And so that's what we'd say. There was a statistically significant difference between the groups on their SAI diffidence egoism scores according to group structure. And then the post hoc tests would allow us to say who did what and what kind of group structure results in those scores.
All of these that we've looked at have this second row in the table that that gives the data for within treatment or within group. How are we to make sense of what's there, or are we to not?
You can. What you're really doing with analysis of variance is looking to see if the difference between the groups is enough larger than the difference within a group, because if the difference within the groups are huge,
Yeah.
the chances of them overlapping are much greater.
Can you say that, what you just said again?
Is there a greater difference between groups, and this is conceptual right now, it's not math that I'm talking,
Yeah.
than there is within each group?
But we're not given, I understand that you wouldn't have an F score within,
Right.
because that doesn't make sense for sort of the
No,
construct.
that's kind of the comparing
But
between.
but we're not given an analogous sort of score to determine whether.
That's true. These are all actual steps in the math. If we were actually doing the math, that would come out that you need to plug into the formula.
Okay.
And so, this computer, did it show you those things? Let's go back a minute. Yes. It looks exactly the same. The sum of squares, the mean squares,
Yeah.
the F.
Yeah.
So it just spits those out for you. I don't care that you know what they are.
Why,
Okay.
why include them on the chart?
A lot of journals are not at this point. Now a lot of journals are asking for the F value, the degree of freedom, and that's it. So it depends on which journal you're publishing in. I think people, because nobody's doing it by hand anymore,
Yeah.
when people did it by hand, you can reconstruct certain things within the data set if you have those numbers and you understand what's happening, which is why they used to put it in. It allowed you to look at whether, it allowed you to interpret to some extent whether there were math mistakes, which nobody makes if they're using computer programs unless they enter the data wrong, and that's not going to tell you whether they entered the data wrong. All right.
I'm confused about, sorry, just
That's fine.
between treatment and within treatment. I don't know if I
That's
should
the
know.
between groups and the within the groups piece. So don't worry about it.
Okay, because those numbers just seem like.
Yeah, what you want, they're
opposites.
nonsense for us at this point.
Okay, all right, I won't worry about it.
If we had done the math, which you really don't want to do, you know, one of these takes like 8 pages of sides in my college ruled books. And the fact that you can just put it into the computer makes me think, why would you ever bother to do that again?
Oh, that's a lot.
Yeah. Okay, so that's one-way analysis of variance. Are we okay on that? It's really not conceptually hard. So now we're going to do two-way analysis of variance, and it's getting harder. Two-way analysis. Why is it called two-way? You remember?
2 treatments.
Two
Levels.
Independent variables.
two independent variables. One that's usually treatments and one that's usually levels. So between all of us, we got all the words we needed. Yeah.
In the Gordon book, do they go by different names?
Might.
Like, oh, now I can't remember what they are, but
There's like
sections and category.
Yeah.
Is that right?
Categories would be levels and sections would be treatments.
Okay.
The number of sections of treatment.
Yeah. Okay.
And what's a MANOVA?
Multiple analysis of variance. Would you like to go there?
No, that's okay.
That would be a good choice. A MANOVA is when there are multiple dependent variables.
No. I
Which
say
we-
no.
Really?
We
is-
haven't even seen designs for that, right?
Well, no. But really, that is what that one that had blunting, the cancer patient one, that's what it really should have been if they had done the right statistics.
I don't,
So, yep. All right, so. Two dependent variables. No, independent.
Okay,
Okay,
guys.
Two independent variables, one dependent variable. And so look for a second at this page 402, the results from two-way ANOVA study. And see if you can figure out what the variables are. What are the two dependent variables, the independent variables, and what's the one dependent variable? sorry.
Responsibility and monitoring.
Look at the top table, sorry,
Okay.
table 1, right? They're
Serving
both table
method
1s.
and age group.
Serving method and age group are the two independent variables. So, the serving method was pre-portioned versus family style in the lunchroom. So they put, do you know what family style is?
Mm-hmm.
When they put one big bowl of peas and kids can take as much peas from that one big bowl as they want.
Suppose like
Which would
buffet
be none.
style.
As a general rule. As opposed to giving each kid a little pile of peas and saying, those are your peas. So there were only really 2 choices. There was the 2 different groups of treatment, the pre-portioned or the family style. And age group, we don't really know how many different age groups, well, we actually do because of the degrees of freedom. There were 2 different age groups, but we don't know what they were. So what was the dependent variable?
Portion of the snack eaten.
Right. So, here is where it gets tricky. Because see that there are 3 F values, right? One of them was significant. It was significant, in fact, with flying colors. We didn't just get 1 star, we got 3 of those stars. And that's sometimes what they do, 1 star for 0.05, 2 stars for 0.01, and 3 stars for 0.001. So that's just another convention.
Like the star chart for research, it was like
Yeah.
lollipop.
Yeah, well, I'm showing you a lot of different examples today, just to give you a sense of the kinds of things you could see and what to do with those, what they mean. All right, now with analysis of variance that's more than one way, the first thing you look at is the interaction between the 2 independent variables. So the SM by A, serving method by age, the F of that was 1.3. And so they tell you, because there's no star, that it was not statistically significant. So, okay, good. Because that makes things much easier to interpret. So that means because that was not, there wasn't one of them messing with the other, it means you can say there was no statistically significant interaction, so then you can go and look at what's called the main effects, which are the 2 independent variables. You can look at their effect separately.
Can you, I'm having a hard time
Yeah.
imagining that, what you're talking about, effect for serving methods and age groups.
Okay, let's say, if it had been,
Yeah.
okay. So let's say we had our four boxes. So far this should look familiar. I better do it from this side or it's going to be, and then I'll move so people can see. So family style and pre-proportioned. Let's say kindergarten and 4th grade, because we don't know what the 2 age groups are. So let's just say that's what they were. So we're going to say this is proportion of snack eaten, but it's not really going to be proportion. It's going to be, you know, how much in terms of grams or however they want to weigh it. So let's say the average eaten here was 3.4. The average eaten here was was 6.8. So the fourth graders in the family style ate a lot more. The average here was 3.8, and the average here was 4.1. All right, so there's not really a big difference here, right? But there is a big difference here. And so, looking at this, you would say, so the age group didn't function in the same way according to the two kinds of serving methods. It seemed to make a really big difference with the family style, but it didn't seem to make any difference at all. So you can't say, you can't really say that age makes a difference, although it sort of, well, you can't say that age makes a difference because it didn't in this condition. Because it depends upon the kind of condition. And you can't say that the feeding method made a difference because it depends on what age. So what you have to say is there was an interaction between the two. The feeding method seemed to interact with age. So you can't talk about age or you can't talk about feeding method. What you then have to do is say the kids, the fourth graders with the family style probably ate significantly more than the other groups. But that there was no difference between the kindergarten and fourth graders when there were pre-proportioned foods. So when the fourth graders have limitless potential, they stuff themselves. So if you're worried about weight gain, what you might want to say is the pre-proportioned food for maybe the way to go, because it doesn't make a difference here, but it does there, and you want to get them to eat less.
But this is an instance in which the two, are we allowed to call them factors?
Mm-hmm.
The two factors interact with one another, or
Two variables, yeah.
Yeah, two variables. This is an instance
In which you
This
would
is a-
have
this is
gotten a significant interaction.
Okay.
There would have been a star right
Yeah.
What if it had been opposite? What if the pre-portion fourth grade score had been super low? So in other words,
Then it still would have been interacting.
okay.
Mm-hmm. And that would have really been confusing. Because, you know, here at least, if you had added it up before, this one would have been way higher.
Yeah.
Now, all of a sudden, they're almost the same
Kind of equal.
across. Yeah. So that would have also been an interaction.
So their serving method preference is a function of their age.
Their serving method, the amount they eat according to serving method is a function of their age.
So that's the serving method times the age row. If that's significant, if that has a significant difference, then the other two can't be.
Well, yeah, you still might find significant differences there, but you don't want to talk about them.
Oh.
Because talking about them is being too simplistic. Because it depends upon, even if you found a significant difference there, it doesn't really mean anything because this information is more detailed and more informational, more useful.
And because there was an interaction between the two categories, we can't talk about you
The
said,
main effects, the two independent variables by
by
themselves.
themselves.
What you do is you jump right from, there was an interaction, to where the differences are between the four groups. But here, okay?
Yeah.
All right,
Very good.
that,
Thank you.
this started out with
Yes.
you, so I wanted to check back in and
It
see
is
how we're
clear
doing
now.
here. Okay,
Thanks
So
for
Scott-
asking though, because I was approaching sort of the
Yeah.
same. Yeah.
but here, we didn't find that interaction. And so then what you do is you go up and look at age, was there